are exactly why I really like Khan Academy. They have good practices for related rates. And this practice right here is having you identify all the numbers. Now, this is an actual related rate question that we can solve. But if you guys really want me to solve it, I can solve it with you guys. But it's just saying, what are these numbers? Okay, the numbers that are in this problem, what are they? So let's go ahead and start reading and see if we can identify all the stuff. All right, this says one diagonal, d sub 1 of t, of a rhombus is decreasing. It's decreasing at a rate of 7. So there's our first number. Let's write that out. Now, it's saying it's at a rate. So I'm going to say d sub 1 dt equals -7. Why is it negative? Because it's decreasing. The rate is decreasing. And why did I do the d over dt? Because it says it's a rate. So I must have the d over dt. Let's make sure we also put the units here because we might as well practice that at the same time. Now it says it, centimeters per minute. So I put the minute right here, not m, just min. Okay, cool. All right, so we did the first number so far. Next, it says, and the other diagonal, you guys know what a rhombus is, right? This is a rhombus right here. Now, all the sides are supposed to be equal, so just pretend with me that my drawing is perfect. Okay, so we have one diagonal right here and one diagonal right here. Understanding the context of the problem. These diagonals, one is getting bigger, one is getting smaller. The other one says, and the other diagonal, d sub 2 of the rhombus is increasing at a rate. So we got d sub 2 dt. It's increasing. See how it says increasing and then 10 at a rate of 10 centimeters per minute. And then it says at a certain instant, the decreasing diagonal, okay, the decreasing diagonal is d sub 1. So d sub 1 at a certain instant at t naught, the diagonal is 4 centimeters. That's what it says, 4 centimeters. Gives you a little label right there. So I plugged in this value of time, which we don't know, but because the problem is saying t naught, we know that it is a specific value. We don't know what it is though. And then it says the increasing diagonal, that's d sub 2, is 6 centimeters at this point in time as well. So let's plug in t naught into that function, which is 6. Now notice that I called this guy and this guy functions because they are. These are functions of t. Okay, what is the rate of change? Okay, now we're to the question. The rate of change of the area a of t. So the rate of change is a prime of t, or it can be dA dt. Okay, now it is saying at this instant. So what it wants is a prime of t naught, or you can say dA dt at when t equals t naught. That one's, you write more on that one, but I like it better. I like the second way better. So this is what the question is. This is what it wants. The units for the area, the rate of change would be centimeters squared and then per minute. Okay, because it's a rate, you always have to have like the per whatever time it is. So centimeters squared per minute. In fact, let's review this really quick. Centimeters would be like the amount, and then if you take the not the derivative, sorry, or length, I should say that length of a side. The area would be centimeters squared, and then the volume, this is all stuff you guys know though. The volume would be centimeters cubed. Okay, all right. So now I've talked about everything that this thing is talking about, and we understand it after drawing a picture and then writing out what the numbers are for ourselves. Let's match the expression with its given value. Ooh. Okay, so here's an expression, a prime of t. We don't know that. That is not given. This next one says d sub 1 of t naught. That is the rate at that, I'm sorry, not the rate. We have it right here. That is the length at that moment. So we bubble in 4. And then this one says d prime sub 2. That's the same as this guy right here. That would be your d prime sub 2. So that's going to be 10. And there you have it. That would be it. That's your answer.